So when someone hallucinates, what are they actually seeing? Like, is it based on the external world or is it something that their brain is completely making up? So this is an important question to ask because it not only tells us about hallucinations, which are way more common than you think, but it also allows us to explain things like people who have very low visual imagery. So I probably have something called aphantasia, which is basically an inability to picture things in your mind. Like if you asked me to close my eyes and tell you what my husband looked like, I would not be able to really describe him. So, understanding how our visual imagery works and understanding how that relates to how we hallucinate is incredibly important from a scientific perspective. Now, as I mentioned, hallucinations are fairly common. So, about 30% of children may have experienced some sort of hallucination, and up to 40% of adults have had some sort of visual hallucination in their life. And I like to bring this up because people are typically afraid of this. Like, if you've ever had a hallucination, even just something as simple as like your phone is vibrating in your pocket, but it wasn't really, you start to get a little bit paranoid. You start to worry about what this means for you. But it is fairly common and it occurs more in times of stress. So we see that about 1/3 to 1/2 of all people whose spouse has recently passed away, they will experience a hallucination of their spouse somewhere around them. But we have this negative stigma around hallucinations. We have a negative stigma against people who have hallucinations as part of their disorder. So, for example, people with schizophrenia or people with Parkinson's. And so hallucinations are not studied as often as they should be. And it's also incredibly difficult to study hallucinations. Like, you can't make somebody hallucinate on demand. That's not a thing that you can be like, hey, if you have schizophrenia and you have auditory or visual hallucinations, come into our lab and then we're just going to like kind of prompt you to have that hallucination and then we'll look at what your brain does. So instead, we do this with a variety of other things, including drugs. So a recent study looked at this with magic mushrooms, also known as psilocybin. And what they did is they basically gave 24 participants either a placebo or psilocybin and then looked to see what their brain was doing while they were actively hallucinating. So they put them in an MRI scanner and then looked to see which areas were being activated and what kind of like patterns of connection appeared. And so they were trying to figure out, are these hallucinations based in reality? So are they something that the visual system is actually seeing, or is it something that the brain is actually making up? And how does this relate to the different types of imagery? So in hallucination, you can kind of have what are known as elementary hallucinations or complex hallucinations. So elementary hallucinations are those hallucinations that are just basically like colors are becoming brighter. So some people say that like if they take mescaline, it makes like everything like geometric shapes, like you are in some sort of weird cubist painting. That is a thing that commonly occurs and that is known as elementary imagery in hallucinations. Then you have the complex imagery. And so these are going to be like more of the entire scenes that come out of nowhere that are not necessarily based on what's around you. And these two types of hallucinations appear to be somewhat different in your brain. So the simple or the elementary hallucinations, the ones that are just like kind of shapes and colors, those seem to be linked to an area known as your primary visual cortex. So this is an area that is taking information from the outside and kind of integrating it into what you are seeing. So this study was looking at kind of that complex imagery and how it relates to our visual system. So what's going on during a hallucination? And what they found was actually incredibly interesting. What they found is that basically hallucinations were kind of turning off the areas of your brain linked to the actual sensation. So basically, you're not seeing what your eyes are wanting you to see. You are seeing what your brain is wanting you to see, if you want to think of it that way. Now, what's interesting here is that the hallucinations that they were asking for, they were telling people to keep their eyes closed. So they didn't want any of that visual input. They wanted them to actually just kind of picture hallucinations without having any of that sensation. And they still saw those inhibition in those visual areas. Now, this works in your brain primarily through what is known as the serotonin 5-HT2A receptor. So there's a specific type of serotonin receptor that's somehow linked to hallucinations. How, we're not entirely sure yet. And how this is all linked to dreaming, we're not sure either. So we think that these types of hallucinations that are induced by magic mushrooms are similar to what we see when we're dreaming. We're not entirely sure because dreaming is just as difficult, if not more difficult to study than hallucinations. Now, we're not entirely sure if this is the exact same mechanism that's going on with somebody who is actually hallucinating due to a psychological disorder. We think that there's some sort of like sensory input differences there too. So for example, people who have auditory hallucinations are able to tickle themselves, but people without auditory hallucinations are not really able to tickle themselves. They think of that as kind of like two different sensory inputs. So there's something going on with our sensory system that we're just not able to figure out as of the moment. So we don't know if these hallucinations are technically the same. And we don't know what's exactly going on with that complex imagery. So those actual scenes that people are making up. We do see that more inhibition of those visual areas is linked to those complex images. But how? Again, we don't know. Welcome to the vast mystery that is neuroscience, which is why I love studying it. But this is important because if we can figure out some of these things, we will understand a lot of different experiences. So first, this helps us better understand what is happening in somebody who is hallucinating. So somebody who has a disorder like schizophrenia or Parkinson's with hallucinations, or even something like Charles Bonnet syndrome, where they have no visual imagery, but they're still having very complex hallucinations. This could also help us figure out what's going on during dreaming, for example. It could also help with things like therapy. So we actually use kind of visual imagery or kind of guided imagery when we use certain types of therapy. So it's really helpful for things like PTSD. So maybe this could help us figure out a better way to go through therapy to help prompt those kind of therapeutic beneficial images. And from a somewhat selfish perspective, it might help with things like aphantasia too. So for example, I have some sort of either hypophantasia, so low visual imagery, or literally aphantasia. If you ask me to picture an apple, for example, so here's a typical kind of non-scientific test for this, so don't use this to diagnose yourself. But here's a typical test for this. Picture an apple. What level of mental image do you have? Do you have no mental image whatsoever, or do you have a really detailed picture of an apple? I have basically no picture of anything. And we see that a lack of visual imagery in your brain is linked to other things as well. So in this article that I feel particularly called out by, it is saying that people with aphantasia also have terrible autobiographical memory, check, prefer science, check, also have problems recognizing other people, check, but can still have incredibly vivid dreams, check, check. I have incredibly vivid and disturbing dreams. So there's something going on with visual imagery and also things like dreaming and hallucinations too. But what? We don't know. Now, the last reason why people should study this is just because it's fascinating. The brain is incredibly fascinating. So take out all of the therapeutic side of things, take out all of the reasons why we need to know this. It is also just interesting to know. So hallucinations are kind of your brain just making up whatever it wants to see by turning off what it's actually seeing. How cool is that?